Hi all, this is Abdullah Abid from live.edu.tv, and this tutorial is titled as how to do port scanning. This tutorial is for the students that love to do scanning of network, learning, ethical hacking, and the related stuff related to securities, and the students of CS, computer sciences, because the information security domain comes under that, and the first of the steps comes under this ethical hacking is the port scanning, through which we can identify that which services are executing on the particular system that we are examining. So this is one of the earlier steps that we do in CEH, port scanning. So that's why in this tutorial we have specifically focusing on the port scanning purpose only. We have divided this tutorial into 4 sections. The first thing will be the ports. You have already been known to this word port numbers, ports. These are usually discussed when we study networks or OSI model. We will review that again, and we will see how we use their port numbers and what are their role in network communication. The second section will be discussing about the different ways of doing port scanning. Different ways includes different type of packets formation. For port scanning, we will discuss about different variants of different configurations of TCP header. We will discuss that too. We will use UDP for port scanning later on. And there are two tools for using port scanning. One is the GUI variant, and the other is the command-based variant. The tool is named as Nmap, and its GUI version is ZenMap. So we will have the basic introduction of Nmap and its installation. I will be using Ubuntu 16.04, hence I will be installing the Nmap on this particular machine. And in the end, we will be discussing about the practical demonstrations of port scanning, how we will do the port scanning using Nmap on any machine or a network, or we can identify the host. So this overall tutorial will cover the whole concept of port numbers, their usage, and identification of open ports, and how we can use that slightly, but we will discuss the usage or exploitation in some other course. But in this we will only discuss about the open ports, what services are running on that ports, and how these are vulnerable, how we can create connection to that ports. These will be the main topics that will be discussed in this section. Hopefully you will learn a lot new information in this tutorial. Thank you.
Hi all, this is Abdullah from live.edu.tv, and in this tutorial we will be discussing about how to do port scanning. I have divided this tutorial into 4 sections. In the first section, I will be discussing about what are ports and their role in network communication. In the second section, I will be discussing about the different ways of doing port scanning, especially the different type of packets that we can use for port scanning. And in the third, we will be using Nmap for port scanning purpose. So there's an introduction to Nmap and its installation. My system OS is Ubuntu 16.04, so the installation will be on Ubuntu. I will include the installation and downloading instructions for the Windows as well. In the last, there will be the practical demonstration of port scanning using Nmap. Okay, this video is about the section 1, the introduction of ports and the role in network communication. This is a very familiar diagram related to networks, that the network communication uses 7 different layers of OSI, that includes physical layer, data link layer, network, transport, session, presentation, and application layer. Each layer has its own responsibility. Now, when we are communicating in the network, we require multiple type of addresses to recognize data for the host or the application. Usually, the very common 2 addresses that are known in networking are the MAC address that is present on the data link layer, and the IP address that is present on the network layer. Now, there is one more address present in the OSI model, that is port number, and that is associated with the transport layer. And the main responsibility of this address is to identify the application. As you can see, this is the source. This is the source system. This is the destination system, and there are some services using between the systems. Now, when we transfer packets, we usually have the destination MAC, source IP, destination IP, the source port, and the destination port. These addresses are must for communication over the networks, and these addresses are followed by the user data. Now, there are some standard processes which have the standard port numbers associated to it, and some port numbers are free for use, like we can assign any port number to that service. Usually, we can say that any process have its own unique port number. Now, let's start from the basics, that we have a client machine and we can use it for many browsing for many web pages, or running different processes on it. Now, each and every process executing on a PC that is related to network communication will have its own address for identification. Let's suppose we have a packet arriving at our system from the network, and we have a lot of services that are active. Now, we have to identify that the packet which is coming is for what service. So we will identify that using the port number. Now, ports and their associated sockets are usually used to identify the process, and the process ID or the port number is identified by a 16-bit number. 16-bit, that means the lowest possible number is 0 and the highest possible number is 65,535. Now, the next thing is port number is simply a number that is assigned to a process, and socket is a combination of IP and port that is used to communicate. When we communicate to any system over the network, we have a socket, and there is a socket on that system that is a combination of IP address of that machine and a port number. That combination is called socket, and it's virtual socket. It's not hardware related anything. So when we open a web page, usually a socket program is initiated, a socket is initiated. That means IP address of that system plus the port number assigned for the new page is assigned to that socket, and we have a combination of that, and we will use that combination of IP plus port to receive and send packets. We can also create port numbers to identify a process uniquely, like we are setting up our system for the database communication over the network. We are setting up a database server, so we can assign a port number to that server, so that whichever system needs to get data from my laptop, so they will require my IP address and the port number I have assigned to the database server. So the services executing on any machine can also be identified using a port number. Okay, as I have explained that we have two sockets, one socket as a source and one socket at the destination, and we communicate between the sockets. Our socket at my machine will communicate with the socket at the other machine, and whenever the process of communication is closed, the socket will be dissolved, and next time a new socket will be created for communication. Now let's suppose we are running multiple processes like telnet or FTP or browsing or simple browsing. Let's suppose we are browsing. We will use the port number 80 for that process number, or port number 80. If we are browsing with HTTPS, we will use the port number 443. Similarly, telnet will use the port number 21. So when we are communicating over the network using the TCP or the UDP, and both the protocols work on the transport layer, we require a identifier that is a port number. Okay, so why we need ports and sockets? As discussed, we have a system and we want to share a data to another system, and my system is sending data to the other system. The other system have the downloading started, they have the Skype working on, they have the update installations, and 5 to 6 tabs are running on their system, tabs of the Google Chrome. Now, when we are discussing these things, a packet arrives at the destination. The destination system will have to check that this packet is for Skype or any tab of the Google Chrome, or it's for the downloading purpose, or it's for the update installation. So thing is, the system has to identify or differentiate between the processes, so we require the port number. And similarly, when our laptop have different services running, let's suppose my system is a server and there are a lot of services running on this. So whenever a request came, we have to identify that for which service it is actually requesting. So the request is generated against a port number that represents a particular service. So for the data transfer, host to destination, or destination to host, we have to have ports and sockets that the endpoints, virtual identifiers that are required for binding processes to a number and then communicating. Okay, if we don't have this thing, the port numbers, then we require multiple IP addresses, and the IP addresses pool is already exhausted, so that the port numbers relieves us on that issue that we have. For one IP addresses, there can be 65,535 different processes that can be launched. So that's a lot. So we can pick and choose from that. Okay, so what is port? So it's a point, processing point present on a system. It's a virtual point. TCP, UDP protocols both can use this port number. TCP has its own ports, UDP has its own ports number associated to it. The incoming data can be identified using that, and when we have the data coming in, we have the destination host and the port number. So the TCP connection will require port number and IP address. So here's the process 1, process 2, 3, 4, TCP, UDP protocol, port number and packet receives. The TCP, UDP identifies the port, which port is first one, second, third, fourth. Each will have its own unique number associated with it, and based upon that, the data is transported to that particular process executing on the application layer. The port numbers are represented by a 16-bit positive integer. That means we have the numbers between 0 and 65,535. Usually, we have divided our port numbers into different sections that are one-lone services and then user-usable services. But like for example, FTP, for FTP, the file transfer protocol, which we use for downloading purpose, has a fixed port number of 21. Whenever we are downloading from any service, we will require the port number 21. Similarly, for the login purpose over the network, when we log in over the network, we use 513 port number. SMTP, simple mail transfer protocol, for the email purpose required port number 25. Telnet for remote connection requires port number 23 over the TCP. As I have discussed that there are a lot of numbers, 65,535, and there are usually most used services over the network, like the FTP, that the HTTP, HTTPS, SMTP, SNMP, login, Telnet, and many more. So we have assigned some fixed numbers associated with some processes, and these are from less than equal to 1024, and numbers greater than this 1024 are usually user level processes that we can use for our processes. Like I gave the example of DB server that I am running on my machine for my own purpose, for my own project, and for my own project. So I can assign my own port number to it. IANA Internet Assigned Number Authority has divided port numbers into 3 categories. The well-known ports from 0 to 1023, that are the fixed ports assigned to the services, most used services. Registered ports, these are registered by IANA, and these can be used by us, and these are not assigned to any specific service. That like we have the port number 21 for the FTP, so we can't use FTP for the DB server as it is fixed for the FTP. So these registered ports are 1024 to 49,151, and the next limit is the dynamic ports. These are not registered, and these are the temporarily used dynamic processes ports. So what's a socket? Socket is actually a combination of IP and a port number. So that means a socket is a virtual point that is used for the communication. An IP is used to locate a system over a network, and port number is used to identify a process on a particular system. That means when we have a socket, we will have the IP address, and we will use that IP address to locate a system, and then we will use a port address to we will use the port number to locate a process on that system of representing that IP. So socket is a endpoint that has IP address and a port, and that used to communicate between the two systems. Like IP address and port number, and the socket is a combination of both IP and port numbers. Socket addressing, transport, when we are communicating, we have both uniquely identified processes IDs, one on the client machine, one on the server machine, and both socket addresses contain IP address header and transport layer header. IP header contains the IP addresses, TCP or UDP. Both the transport layer protocols have the port numbers associated to them. We have we can only have a TCP or a UDP header included. Now, socket communication, we have a client. When it will request a connection for a particular port, that is a requesting port. That server is assigned for accepting the request. Server will accept that and then create a new port, create a new socket, and then will communicate with the client using a new socket. And the older port will be used for receiving new requests. Okay, that's it for section number 1. Hopefully you have a little bit understanding of ports, numbers, and sockets. In the next video, we will be discussing about different ways of doing port scanning. Thank you. Hi, welcome back in the section 2 of how to do port scanning. In this section, we will be discussing about the different ways of doing port scanning. In this section, we will be discussing about the different type of packets that can be sent over the network for the purpose of port scanning and how the responses are interpreted. First thing is that why we need to do the port scanning process. Port scanning is used to identify the open ports present in a system. Whenever a process is running on in a system, that port is open. That means we can communicate to that system using the open port. If a port is closed, we cannot communicate with that system using a closed port. So we need an open port for communication with any system. So whenever we are in a network and we want to communicate with any system, we want to locate all the open ports present in the remote system so that we can launch any attacks on that. So the first thing will be the port scanning. So that, and as we have discussed in the first lecture, first section to be exact, we discussed that that ports are assigned, port numbers are assigned to every process. That means if any port is open on a remote system, that means we can suspect an open port response to service running on that system. Like if we have a system and we usually perform HTTP browsing, HTTPS browsing, so port 80, port 443 are usually open on any system. So ports scanning is used to identify open ports, and port scannings we want to identify
the number of ports available open, so that we can probe which services are running on that, and so that we can find the vulnerabilities on that system. So when we have to attack, then we have to attack using different methodologies, different type of packets, and we have to verify each and every port, so that we have to attack from port number 0 to 65535, so that each and every port open on that system can be checked. We usually divide state of the ports in 3 points: open, filtered, and unfiltered. Open means the target machine port or process is running, and its port is open, and it is accepting the request or accepting the messages on that port. So that port is open, and this open port is vulnerable, and we can attack. We can send a message which can create a vulnerability which can exploit the other system. Second and third, filtered and unfiltered, are relatively in better positions. Filtered means there is a firewall or a network filter that is stopping the connection to that port. That port can be open or closed, but there is a firewall that is blocking the communication. Unfiltered means the port is closed. So open means the target machine is accepting the messages or the port is available for the communication. Filtered means there is a firewall or any kind of packet filter that is limiting the number of packets reaching to the open port, but the port is open in the filtered domain. Unfiltered means the port is closed. And when we will discuss the different techniques, we will discuss about that this technique will tell about the open port, closed ports, filtered ports, or unfiltered ports. Each and every technique will have its own idea of guessing the state of the port. The first way of doing is the TCP connect scan. TCP connect is a basic TCP three-way handshake methodology that is used. TCP scans send a SYN. SYN is the flag in TCP header. We usually communicate over the network having a TCP header when we are using TCP protocol over the transport layer. So there are 7 flags in the TCP header, and we can on and off those flags using the bits 1 and 0 on the respective positions. So if we are saying that SYN is passing through, that means a SYN flag is 1 and other 6 flags are 0, plus port number 21. Port number 21, remember, this port corresponds to FTP. That means this source is sending the request of downloading to that destination, and the destination replies with the RST. Reset is another flag of TCP header. That means reset means the port is closed, and if SYN is passed with a port number, as we discussed, that port number 80 is usually open on all systems. So it will have a reply SYN plus ACK. ACK is another flag. So SYN plus ACK, 2 flags are active here, and it is response. So source have the response. So this verifies the port is open with the presence of this ACK. If we get, sorry, that's my mouse is something going wrong. Okay, so that ACK presence shows that there
is an open port and we can attack that. Now, so this ACK represents port 80 is open, and we, if want to repetitively check, we have to change the port numbers there. We have certain advantages of this methodology, as TCP connection is usually created this way. So these packets are usually created in the applications, but there is a bad thing about it, that whenever a connection is created, connection request came and connection is created, it is stored in logs. So the logs will have the information about this, and when we have the screening of the system attacked from the outside, we can get the information about the source or the attacker, that which system, or to be specific, which IP generated the request. So the advantages: no special privileges, it's a normal routine communication, three-way handshake methodology. So no extra packet or no extraordinary packet created, and so no additional privileges required, no additional rights required, no special packet creations or header configuration. So it's normal communication way. But the disadvantage is the log or logs which we can be checked, so that if the IP which attacked the system can be analyzed. TCP SYN is in this scanning, we do half of the handshaking process. In this, we send SYN plus port at port something, and we get a response of reset. It's a close post. But while doing the open port process, we, when receive SYN plus ACK, we send reset. That means there is no completion of port. In the previous case, TCP connect, we sended ACK plus reset again, 2 packets. First was ACK, then reset after receiving SYN plus ACK. But it's a complete connection created. But here what we are doing is we are receiving SYN plus ACK and we are sending reset only. So when we are receiving SYN plus ACK, so it's the same thing, that it's a port is open, but the connection is not completed. Hence, it's a half open scan. We are just not completing the three-way handshake. We are doing it the halfway. So advantages: TCP SYN scan never opens a TCP session, never completes a three-way handshake. So it's a quieter way of doing scan. These type of packets can actually check the open ports. And secondly, we have the disadvantages, so that we have to have privileged access to the system. If we don't have, then we cannot create half open connection process. So privilege is required. That's a disadvantage, but the advantage is the tracing can be difficult in this case. There's another scan, that is the stealth scan. This scan can be of 3 types: FIN, XMS, and null. In this scans, we do not use the usual TCP way. In the previous 2 scans, we used typical TCP three-way handshake methodology, but in this we do not use that methodology, but we are using the other flags present in the TCP header. We already know the SYN flag, the ACK flag, and the reset flag. Now there are multiple more flags present in there, so we will be using that flags in the stealth scan. So these will not be using those three-way handshake methodology in these. So first one is the FIN scan. FIN is another flag that is present in the TCP header. So it's the 4th one. SYN, ACK, reset, and FIN. FIN is the 4th one. So FIN scan are one of the stealth scans that can be used. So it's work on the principle that packet in which fin flag is active plus port number 443, it's HTTPS, and if we get a reset as a response, that means close port. If we didn't get any response, we send a fin plus port at port something, and we didn't get any response, that means the port is open. The next thing is we use the XMAX scan. XMAX scans have the privilege to set all the bits 1. We have the fin flag 1, urgent flag 1, push flag 1. Urgent and push are the other flags present in the TCP header, plus port number, any port which you want to scan. And if we get a response, that means a closed port. If we didn't get any response, that means a open port. Null scan means we have to turn off all the flags. No SYN, no ACK, no reset, nothing. No fin, push, urgent, nothing. We have to set all flags 0, and we send that plus a port number which we want to scan to the destination. And if we get a response, that means it's a closed port, otherwise open port. So first advantage, the previous two technologies that we discussed, that TCP connect, TCP SYN scan, in both these we use the typical TCP connection methodology to check the open ports, but here no TCP connections are created, so there is quite way of doing scanning. No one can get any information from the logs. Secondly, it's a most easier way in which we have to create or send the least number of packets over the network. And the disadvantage is that if we didn't get any response, that may be due to the network response, maybe network may be choked, or so that we didn't get any response, or maybe due to any issues. But if we didn't get any response, that doesn't 100% means the port is open. So that probability is here. Secondly, root privileges is required on the user side, which are scanning the other system. So if you are attacking, you need to have the root privilege of the system. Secondly, it is platform dependent. Like any device showing open ports must not be a Windows based device. That means if that is a Windows based device, that result cannot be trusted if we are using stealth scan. So if we are attacking any Linux based system, that attack, this 3 attacks, fin, XMS and null, will be very helpful. Hello again. This is section 4 of how to do port scanning. In this section, we will have the practical demonstration of port scanning using Nmap and Zenmap. In the last section, we discussed about how to install Nmap and Zenmap on Ubuntu 16.04, and along with that, we discussed why Nmap is preferable among other tools for port scanning. Let's divide this particular demonstration into 2 parts. First one will be the Zenmap, the GUI part, and in the second part we will discuss about the usage of Nmap. So let's open the terminal, because when we launch from the application, it says non-root user. You are trying to run ZenMap with a non-root user. Some Nmap options need root privileges to work. That means we cannot execute ZenMap when we are non-root user. We can use that, but some functions, some packet generations might be not allowed when we are using the non-root user. So there must be root user when using ZenMap, so we have all the options available. So we select OK. It opens up, but main, let's suppose this thing might be unavailable to execute. So let's close that and let's try to run it as the root. We open up the terminal. We write it sudo su, enter. I have my password for the root, enter, and now I have here I have a root at PC. That means I am now the root. So now let's run a ZenMap, and here it's again. Now we didn't get that error of the root user, so here we are. So here is the ZenMap. So this is the window of ZenMap. I'm explaining ZenMap earlier because usually it fascinates the users, because we don't have to write the commands, although we have the space here to write commands, but we can use it without commands. So here's the target. That means the network or a system which we want to scan, the type of scans, the command, the outputs, Nmap output, port, host, topology, host details, scans, and different. So let's start from a basic thing that let's suppose my IP is currently my IP is 192.168.100.8, and so it's /24. So that means let's first start by checking how many systems are there in my network. So I will write nmap dash s capital P. SP is for the ping scan, that is used for identification of systems over the network. Then I will write 192.168.100.0/24. That means the whole subnet. It will run on the whole subnet. We can use 10 here. Let's use 1 here. /24, and now it will scan the whole subnet, and it will identify the live systems available. It's starting. I have the version Nmap 7.01. So 256 IP addresses are possible because it's a class C IP, and 15 hosts are up here. So we have much systems available, which includes the 10.1, that is the main gateway, then 100.2.3.4. It tells about all the systems available, and we now have the option of scanning any of these available, or we can scan a simple website using here. So the first thing we learned is that if we want to target a complete subnet, we can ask them 192.168.100.1 slash the subnet, and here it represents the subnet. So we can say it's scanning the network. But let's suppose we want to have a range of IPs. So let's suppose we enter 1-20, that means 1 to 20 only, and when we enter that, now it will only scan the systems that are present from 1 to 20. Here is the 20, and it's not representing any system that is beyond 20. And when we have this /24, now it will have 28, 29 and different IPs in it. It's running again. Let's wait for the response. Here are the list of hosts that are available. Now the 12 hosts are up in my network, and let's see the second tab in it. This is the descriptive tab and map output, and now we have the second port, that is port host. We doesn't have any host scanned for the open port, so it's empty. Topology, it is giving the topology output of how the different IPs are connected. Host 100.1 is up, 100.2 is up, 3 is up, 4, 5, 6, 5, 7, 8, 12, 14, 15, 16, 17, 18. All the state are up. We haven't scanned these systems as yet, so it giving no details of this ports. And scans represents in the commands that we executed. Let's suppose we want to let's scan a certain IP among these. Let's suppose we have 192.168.100.29, and we have the profile of intense scan. It is so when we give the intense scan, it provides me certain information. It's running still. Let's wait for the result and then we will discuss about it. So the scan is complete. So we have ops ping scan executed for the liveliness and then scanning. So one important thing here to discuss is, here's 1000 ports. That means the default, we haven't said that that check the number of ports, so it's the default number of ports to be scanned is 1000, and these are TCP ports. If we have to scan all ports, we have a command, and we will discuss it later. So the first thing is discovered open port 445, that is representing the HTTPS service. 139, 135, the two other ports are open on this system, and when it can scan the OS, we have discussed that, but here it is reluctant because we are not discussing anything about that, so that is not related to our topic. When we are coming to the service, this is Microsoft remote process call. 135 is active. 139 Microsoft Windows 98 NetBIOS is active, or 445 Microsoft DS is active. So that means these three services are active on this particular system. And when we have the host detail, now we can see the scan ports are 1000, total ports 997, closed ports, open ports are 3, and the operating system Microsoft is using, and it provides accuracy of 95%. That means it is 95% sure that the operating system uses Windows, but it can be other. So we can try some other also. Let's suppose we can scan 28, the other system present. Here's the stealth scan. That means it's using stealth scan is executed here on 1000 ports because we haven't set for the whole thing, and now no ports were detected as open here in this system or in this machine. So let's check for 21, and similarly we can scan all the systems present in that network, and we can get the details of each and every thing that is present. Host is down, so it's blocking the pings. So the liveliness of system is because it's not now present. 21 is removed from the network. I am running all the scans on a live network, hence the systems came and removed one by one. So 20 is removed also. Let's try 12. Hopefully that will be active. MAC address is Huawei Technologies. That means Huawei represents a mobile phone. That means Huawei. That means this IP represents a mobile phone here. So you can scan different machines from that. We have intense scan plus UDP. UDP is the another protocol that we can be used in the transport layer if we do not use the TCP. UDP is usually used in the live streaming or the real-time applications, and it doesn't require any handshaking. It just sends the data and trusts the system for receiving or trusting the network. So if we send a UDP packet, there's no such flags present in this. So if we send a UDP at a particular port, and if we get ICMP response, ICMP is another packet protocol that is used. So if we get ICMP response, that port unreachable, that means a closed port. If we send a UDP packet with a port number and we receive a UDP packet, that means an open port. If we send UDP and we didn't receive anything, that may be the filter, that maybe represents a filtered port. ACK is the same TCP, but in this case we are using TCP ACK. That means only the ACK flag is 1 and the all flags are 0, and if we didn't get a response, that means a filtered port. filtered by a firewall or a packet analyzer or something, and if we get a response of reset, that means it's an unfiltered port or it's a closed port. Windows scan. Window is the size of number of packets which can be sent. So window size is important in scanning. Window size is usually set during the communication. It usually changes during the communication. Like in this, we send a TCP ACK plus port 25, and if we get window size is equals to 0 plus reset, window size 0 means no packet is no packet can be accepted, so it's a closed port. But if window size is 4096, that's the default value. So if we get that value, that means it's an open port. So if window size value is 0, that means a closed port. If window size has something in it, so it's an open port. So it's the most simplest of attacks in which the single ACK is active and we are checking on the window size of parameter operator on which we see if the Windows parameter is 0, that means a closed port. If Windows parameter has something, that means the port is open. So but Windows scan doesn't work on all set of devices. Some operating systems may be vulnerable at this, some maybe not. Some systems may be vulnerable, some may be not. So if we have upgraded systems, we usually update our systems, so might be the Windows scan will not give any useful information about the open ports. The RPC scan is a remote program call scan, that is to use the remote applications, and if we send the remote program calls against different processes to the other system, and if we get any response, that means the process is running and we can attack that process. So in this in this scan we actually check the processes, not the ports, and we need to know the common processes that we expect that can be running on the other system, so we can scan that. IDA scan is something in which we use a third system, and using that system we do the vulnerability scanning. All the previous scanning techniques were implemented between the two systems, the attacker and the victim, but here we have the third idle host from the victim's network, and what we do is IP ID probe is number get from the host, and IP ID response is get from the idle host. Any active host will get that response. So we have the 1 2 3 4 5 IP ID from the idle host, and we attacker get to know that. Now the next thing, attacker send the victim the same and get the response from the analyzes the response from the idle host. Now what happens is attacker sends a SYN packet to the victim from the idle host. It hacks the identity of the idle host and represents itself as the idle host, but it's the attacker. Victims understand the packet and it checks the address. It's from the idle host. It responses to the idle host, and then idle host responses to the victim that it's a reset. I didn't send you any packet. It was from the attacker. So attacker again probe the idle host, and if the probe ID is the one more than the previous, that means it's an open port, otherwise a closed port. We have IP ID of 12345 earlier, and then in response 1234547. So that means increment of 2 represents an open port. If we have only one increment, IP ID 12345, next time 12346, that means a closed port. FTP bounce attack is another attack that is used using the third party and using a third FTP server which may be deployed at any point. So in this we use a particular destination and we send that to the FTP server, and FTP servers forward that to the destination, and if we get reset from the destination to the FTP server and FTP responds with the error message that can't build the data connection, that means a closed port. And if we get the transfer completion acknowledgement, that means the port is open. So in this we are just sending the data to the FTP server and we are telling it that please upload that data to the destination, and if successfully transfer the data, that means an open port. If it fails to transfer the data, that means a closed port. So that's it for the scans. One thing that I want to discuss is we have a lot of scans studied in this section, but we need many scans or multiple scans so that we can get the information. Some attacks works on some systems better than the other, so we have to have multiple choices available so that if any ports or any system denies a particular scan, it can be we can get proper results using some other scan. So we have multiple scans. If something we cannot get any appropriate messages from, let's suppose, stealth scan, that means we can using FTP bounce, or we can scan using XMAX or something, TCP connect or something like that. So we can have multiple options so that we can trust the results obtained after the all the scans. So that's it for section number 2. We will start section 3 in the next video. Thank you. Intense scan plus UDP, intense scan all TCP ports, that means all the 65,000 ports available. Let's suppose we run that on the first system we executed, in which we have the 3 ports active. Let's run that. Now we have a much more bigger range of ports that we have to scan, so it will take some time. We will wait for the results and we will discuss that. It's only 3.82% done yet, so it's 13 minutes may be remaining. So we can say that it will take time. The process of Nmap is it randomizes, randomly generates packets to different ports. That first packet for the port 1, then the port 900, then 712, and similarly. So it will have a different mechanism, and different random mechanism of selecting port, and then we can linearize this, but by default Nmap uses the randomization process of port scanning. So it's only 6.10% done yet. So one more port open discovered, and that is 63,643. That means one more port that was not discovered earlier. Now it's available. So we have this port open. We can exploit that too. One more thing, when till the results came, we have one thing over here is 1-65535-P. So dash P means the port range, dash P means port range, and 1-65535 means we have to scan ports from 1 to 65535. So it's the range. We can change the range, but here the full range is given to that. So whole range is assigned. We have only 10% of the time done here only. So we are waiting for the results. Till then, we can see here the ping scan, we have the quick scan, trace route, slow comprehensive scan. It's a time taking process. It takes times more than even the intense scan all TCP ports that we are running right now. Only 10% done in the previous some minutes. It will be running. It's running, and when we have the ports host, only previous results. Now when we have the previous results, it shows the port is open, TCP, and the services and the version of that service. So when I was telling that when we attack some system, we usually have this version is very important in that. If it's the older version, we will easily find the exploits on that than the newer versions. It's 12% done only. So it's running. Let's cancel this. We can also scan a particular web address. Let's suppose my friend's website is zqforensics.com. It's for his project, but let's scan that. We don't have time, so it's for intense scan only. So we can have the execution at the small time. So there's a lot more ports available here: 389, 135, 110, 53, 3306, 139, 80, 445, 443, 143, and 21. Also, we have 49,155 TCP port active, 1433 active, 42 port is also active. So this is a lot of ports active. So when we have a lot of ports active, so that means we have different services running on that website, and we have quite a complete picture of that website which we can analyze. $49,153 is also active, 26 port is active. Usually port 80, port 139, 135, 443, 445, these are usually active on any system, but these are so many ports, so we will look that how many ports, which services are running on these ports. It's initializing the service, which is the main purpose of the port scanning. We have the ports, we can create sockets on this, we can have the communication request on these, but we need to get the services which are running on this system. So let's wait for the initiate service scan so that we can get the services results, which will tell about which services are running on each of the ports we have scanned open. OS detection failed again. We have retrying and so we don't have a clear picture of the OS, but there are a lot of the services that is running. The trace root is available, the MS SQL information is available, the OS guesses are the Windows server, as it's a website, so it probably will be the servers. Here are the different set of keys and available, like RSA key, signature, MD5 of that key, SHA-1 key, TCP, SMTP, that means email enabled, so that email is also enabled. We can attack using the emails. 110, it's the POP, that means again emailing server protocol, IMAP email server protocol, again SSL for the HTTPS service, which have the security points in it, SSL certificate associated with it. So we have quite a lot information with using this particular scan when we run that. So we can have the trace route complete here, that from which it passes to the other systems and so on and so forth. So here's a lot more information that is present. So we can use this, and this information will be very helpful when we are attacking any system. Let's suppose here are the just have a look at this. These are the systems these are filtered ports, remaining are the open ports, and MySQL, Microsoft Windows Server, NetBIOS and all. So these all are active. So these all are the active services in this. So this is a brief introduction about using ZenMap. Some commands are remaining. We will discuss about some basic commands over the Nmap part. So that's it for ZenMap. Hopefully you have understood the usage of small introduction. This is a very vast tool. We can't explain each and every bit here now, but it's a basic introduction. We have some more commands when we will be explaining the Nmap. Thank you. Hello again. We are back with the section 4 remaining part, in which we will be discussing about Nmap demonstration. We have done the demonstration of ZenMap, the GUI part. In this part we will be discussing the command based Nmap. So here is the terminal. Let's first go to the root so that we have all the privileges to execute. We are into the root now. So we have Nmap install. Here are the different set of commands that we can use.
So let's run the first thing that we executed at the ZenMap2, that was nmap-s capital P 192.168.100.1/24 ping scan to identify the host. Press enter, starting nmap 7.01 at the time, and different users are up. We have the 1, 2, 3, 4, 7, 11, 12, 15, 17, 18, 21, 22, 28, 29, and the 8. So 15 hosts are up now, and the scan was completed in 8.62 seconds. So it's the same output irrespective of the GUI. We have the output here, and we can have the scan of, let's suppose, nmap 192.168.100.29. So we are running the scan over .29, and the same stats which we got there, that is 135, 139, 445 are active. So we have successfully got the results which were required. Now coming towards the other commands, we can similarly have the website that we used, the ZQ and thing. So we can add that. We know how to do that. Now the thing is, let's suppose we have the targets we have saved the targets in one file, and we want to run that file. So we can have that. Let's suppose we have a file, and we run that using -i capital L space file name .txt. Let's suppose file name .txt is my file, so in which we have the IP addresses, the subnets, each and every destination to be scanned is saved in this particular file. So we can run this in this pattern. We can execute this file for scanning. So next thing is we studied that we can run only TCP connect. So this -st represents the TCP connect scan only. So let's run that. Only TCP connect scan is executed. We can have the other ways like S for the TCP SYN scan. So similar results from the TCP SYN. We can have the UDP using /2/p. We have /p. So let's start. We are scanning the UDP ports. We can also have the Windows scan that we studied in lecture section 2, in which Windows scanning, window size is used. So in that we have -SW, capital W. For the fin scan we have -SF, F capital. Null scan will be -S capital N. XMES is -S
capital X. Idle scan will be dash S capital I. So these are all the different ways of doing the scanning. The UDP is taking time, it's running for all the ports. We can wait a bit, but there are a lot more commands in this. Let's quit this, and we have dash F. Dash F represents the most common ports used, will be scanned only. If we want to scan all, we have to give the range. If we want to have the ACK scan, we can have dash SA. And similarly, we discussed about that usually when Nmap scans the number of ports, it randomly selects the ports, like it's not sequentially scan all the ports. If we want to sequentially scan the ports, we can use dash R with as capital T. We haven't defined the ports range. That means it is defined as 1000. So dash R means a sequential first 1000 ports will be scanned. So that means these are the different commands that can be used for the scanning purpose. We can have the GUI part. We can use this part. Both results are the same, but Zenmap results display are better to understand for a newbie. So both platforms can be used for port scanning. In short, in this whole tutorial we discussed about port scanning, what are ports, what are sockets, and then how we can scan ports, what are their utilities, why do we need to scan ports, and then we introduced ourselves to Nmap and then its tutorial. So hopefully this all lecture will be helpful for you to understand port scanning and the related points. Thank you for listening. Goodbye.